In this video, we have the integral of secant squared theta times tangent theta d theta on the interval 0 to pi over 4. And what I notice immediately is that I have a function, tangent theta, sitting right next to its derivative, secant squared theta. So the informal approach to this problem is to just recognize the chain rule backwards. So just to highlight that, I've got the derivative of the interior function sitting right next to that function to the first power. And this allows me to just use the power rule to find the antiderivative. I just add 1 to the exponent of the tangent function, divide by the resulting number, and then that secant squared piece, that's just the chain rule differentiating the interior functions. And so adding 1 to the exponent here, I get tangent squared and then divided by 2. So I'll write it as 1/2 tangent squared theta. And just as a quick check on our work, if you were to differentiate 1/2 tangent squared theta, the chain rule says differentiate with respect to the interior function. In other words, treat the tangent function as a single variable for a moment. So I bring down the 2 in front, and then multiply by the derivative of the interior function, which is secant squared theta. The 2's cancel when I get back to where I started, so I know I've done this correctly. To wrap things up, I have to sub in the limits of integration. So I have 1/2 and the square of the tangent of pi over 4 minus the square of the tangent of 0. The tangent of 0 vanishes, and the tangent of pi over 4 is just 1. So I end up with a 1 squared, or 1. And multiplying by the 1/2 out in front, this integral evaluates to 1/2. What about the formal approach to this problem? I still have to recognize that I'm looking at some kind of a function next to the derivative of the interior function. In other words, if I go back to this step, I recognize it as tangent to the first sitting next to the derivative of the tangent function. So I'm going to let u be equal to that inner function, tangent theta, and then du is secant squared theta d theta. And I'm going to take the approach of just transforming the limits of integration in terms of u in this example. So when theta is equal to 0, u is the tangent of 0, which is 0. And when theta is equal to pi over 4, that's the upper limit of integration, u is equal to the tangent of pi over 4, which is 1. So then we rewrite our integral. That's going to be the integral as u goes from 0 to 1. And then the tangent theta piece, that's just u. And then the secant squared theta d theta piece, that's just du. So I have the integral from 0 to 1 of u du. And this integrates to 1/2 u squared, evaluated on 0 to 1. When I sub in the lower limit, I can see this is going to vanish. So all I care about is the upper limit, and I get 1/2 times 1 squared, or 1/2. And we get the same answer. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.